Hi everyone, good morning. I'm Yotam, very happy to give this talk, albeit remotely. This is based on joint work with Ronen and my PhD advisor Moshe, and it's called Prediction Sharing During Training and Inference. Okay, so the basic setup that we are going to consider is where we have these two firms that operate based on some machine learning model that they have. And they basically need to come up with a binary decision eventually, and they try to base it on their data. So for the purpose of this talk, we will consider loan issuance. Okay, so the most basic thing that they can do is just each of them have their own data sources. They train a model based on it. Then when users come in real time and they have their specific set of data, then they input it into the model they developed and come up with a decision. And each of them does it separately. The question is, can they do better? Can they somehow share information in a way that will inform their decisions? So in some ideal sense of what they could do, they could just operate as a single firm. This is like some comparison that we can make. They join all their data sources, train a model together, and then in real time, they operate based on the joint model. But this has several issues. One is privacy. So they let the other firm have access to their user data, which violates the privacy of the users, but also the proprietary property of the firm. And also there is the issue of cooperation versus competition. On one hand, as a joint entity, maybe they have better predictions, but maybe in terms of the firm's utilities, it doesn't work out for the firms to actually pursue this. So we can imagine a more limited model of data sharing. Each of the firms train their own model, or maybe they already have the model that they developed. But now they get acquainted with the way the other firm operates, so they can compare their predictions and build a joint model over these pairs of predictions that decides what to actually do eventually, like a joint decision based on that. And in real time, they will also share the prediction signals and wrap it into one joint decision. So both of them will offer the decision, and they will again share the revenue of the of what happens. But still, maybe this wouldn't be justified in terms of the firm's utility, especially we are going to consider a primary firm and a secondary firm. So maybe one of the firms is better informed and has better models than the other. Yeah, so other two maybe natural ways of sharing that the firms can pursue is that they do share their own predictions and they do know, I mean, their own historical predictions. They can know how the models interact with each other, or where do they complete each other or correlate to each other. But in real time, they don't share their prediction values. Okay, so this is kind of like learning to know what the other firm is doing, but without knowing in real time what the other firm is predicting. And they can have inference sharing, which is the opposite. You don't know the historical correlation between your model and the other firm's model, but you can see the signals of the other firm. You just maybe get it as a as another resource to help you inform your decision. So after there is a layer after the model outputs some prediction, you consider the signal from the other firm, and you decide your final prediction. Okay, and we call this forms of partial data sharing. Okay, and so eventually our research question is going to be, we have these 4 different ways of sharing, or actually one of them is to not share. And we want to know when are the firms going to decide on one of them. And the conditions that we put forward are individual rationality, in the sense that we want the type of sharing to be better than no sharing for both of the firms, because if it's worse than no sharing, then the firm would just not agree to it. And also we want it to be Pareto optimal. So if it was the case that there are 2 different contracts that are better than no sharing for both firms, but one of them is better than the other one for both firms, then we would expect them to go for the Pareto optimal one. Okay, so now we're ready. All of this was like not concrete, but now we can have a model to reason about this situation. Okay, so the firms have a prior over priors the world. Eventually, there is going to be the true binary state of the world, yes or no. Is the user going to repay the loan or not? Okay, and given this state of the world, the firms could get a signal in real time, also a binary signal that the model gives to them of whether they predict yes or no. And we're going to call it A and B, or capital A and B and non-capitalized A and B. But they also need to know the performance of the model. So the first signal they get, which they get during training, is which world model it is. Okay, so the first thing that the firms learn is they learn the behavior of their own model. Okay, how much accuracy it has, what are the chances of correct prediction. In the second stage, which is optional, it depends on whether they share this information or not. And the firms can also learn the other firms' signal distribution or model performance. And based on these 2 different signals, they can compose the joint distribution. So they can actually uniquely determine the correct world model. Okay, and then when we get to the prediction stage, so we have one sample of a single new user, and based on the distribution, we get a signal, and then we need to decide what to do about this user. So anyway, we get our own signal. So the firm gets its own signal, but they can also share the signals. So in that case, they would have a pair of signals. And then after all that, the firms decide on an action. And the different contracts that I mentioned before map exactly to whether you do the optional sharing stages, any combination of them. Okay, and now that the firms have made their prediction, they're going to be rewarded or negatively rewarded. So it depends on what was their prediction, the actual outcome, and the other firm's prediction. So let's say that the firms disagree, then if they correctly predicted, then they would get some reward. And if they incorrectly predicted, they would incur some cost. And if the firms do agree, then everything is halved. So because they make the same prediction, maybe they approach the user with the same offer, and with probability half, one of them is chosen. So so if it happens that they agree, then everything is just split between them. Oh yeah, and now that we have the dynamics and we have the utility model, the firms fixing a contract, the firms can calculate their eventual utility depending on their strategies, and they can reach an equilibrium. And we're going to score each contract based on the expected utility at equilibrium. And then we will have this kind of mapping between the contracts. Okay, and we're going to make things a bit easier, we're going to consider a specific model that is a bit limited. So first of all, okay, when you issue a loan and you decide not to issue a loan, then you have no risk and no reward. So you anyway, you passed on this user and you're not going to get any reward, but also not incur any cost if you fail to predict correctly. On the other hand, if the user doesn't pay the loan, then you bear some cost. And if they do, then you get some reward. We are also going to assume that it is common knowledge that what are the prediction accuracies of the firm. Maybe this is something that the market already figured out. So we know that, I mean, as the primary firm that predicts better with probability alpha, they know how well they predict, and they know how well the other firm predicts. But the one thing that is left to figure out is what is the correlation between the predictions. And maybe the secondary firm is totally taken over by the primary firm. So every time the secondary firm predicts correctly, the primary firm also predicts correctly. Or it might be that they capture different cases and it's less correlated. Okay, so eventually in this more limited model, it all comes down to the correlation between the signals. So let's consider, so now we're going to analyze this case a bit. So let's start with the most simple subcase of this case, which is a known correlation. So we actually have a very specific world model that we already know with probability 1, that this is the world model. So everything is known up to the inference stage. So yeah, so stages 1 and 1b are redundant. We don't learn anything new during these stages. Now, under full sharing, you can show that the equilibrium for both firms is to just follow the stronger signal. Okay, so you go by the capital A signal by the primary firm. But under no sharing, there are two regimes that might happen, and this depends on the relation between beta and alpha, the accuracies of the two firms. If the secondary firm has good accuracy, then this firm will also follow its signal. Okay, so both firms will just act upon the recommendation of their machine learning model. But if the secondary firm doesn't have good prediction accuracy, then they would just exit the market. So the secondary firm would never predict yes, and they would never issue a loan because they're less informed and they can only lose money by doing that. But given this analysis, we can show that the primary firm wouldn't want to share anything because they have the advantage in this market, and so no sharing is going to be the outcome. Okay, but what if the correlation is not known and also there is no symmetry in the cost and reward? Okay, so this is a more general setting. So in this case, full sharing can happen and is going to be individually rational and Pareto optimal sometimes. So how can we explain it? Let's think about the firms having the same prediction accuracy. Then the firms are symmetric, so under no sharing, they're going to behave the same way. But under full sharing, they're also going to behave the same way because everything is also symmetric there. But both of them are more informed. They know the correlation, they know the pair of signals when they make the final decision. So they don't think in expectations, but they can think in more granular. It's still expectations, but maybe expectations over a smaller uncertainty. So they can get some advantage. So this is a good case for full sharing. When would train sharing happen, where they only reveal the models, but they don't reveal the signals in real time? So sometimes full sharing, when the accuracies are not symmetric, full sharing is not good enough for the primary film. So this is not an option. Now, if you remember 2 slides ago in the non-correlation case, firm number 2 has 2 different equilibria that they might follow. Either they exit the market or they follow their own signal. Now, in expectation, if they don't do the train sharing, they would need to go on expectation on one of these options. So they would have to go for the option that is on average on the correlation, the option that is better. Okay, so it might be that the option that is better is to follow their signal. But the 2 firms can gain an advantage from informing the secondary firm when to exit the market. So with no sharing, they just follow their signal. They always follow their signal. But with train sharing, the primary firm can reveal something that would make the secondary firm leave the market. And that's good for the secondary firm because they understand that they're going to incur loss here on average. And it's good for the primary firm because they don't have to share the revenue. Yeah, so this is the case for train sharing. And for inference sharing, we know that within this model, it wouldn't be the optimal contract, but there are settings where it is a good contract. And in these settings, what basically happens is that even though you don't know the model of the details of the model of the other firm, you can use the other signal as a coordination device to offer different options for the market. So this is not going to be like the low issuance case, but it's going to be maybe you make different offers for the market, and knowing that the other firm has a different signal would be useful for that. Okay, so that was very short. If you want to hear more or talk with me, then I'd be very happy to do that. Okay, so thank you.